Can we start today's session?
Yeah, teacher.
Okay,
You can
right,
start.
fine. So, once again, very good day to everybody. So, we are back with another subject, which is Introduction to Computer Systems. So, unlike the other subject, like Introduction to Computer Science, we are dealing more with the programming. But with this subject, it's more theoretical part. Like we understand the history of computer systems. Like we study, we get in touch with the first generation, second generation, third generation, fourth generation, and fifth generation computers. And this particular class, we would go with the introduction to computer systems, with the computer introduction, evolution of computers, classification of computers, and application of computers. Okay, so like in this particular class, again, I'm going to give a live demo about our subject. Okay, I hope everybody will definitely get the subject materials, maybe via WhatsApp or maybe via email groups even. So I'll discuss with Furkat regarding with how to send the materials, okay, every now and then, so you get in touch with the subject. So this is especially for students and young researchers, and this is Dr. Christo Ananth for you. You can reach me at dr.christoananth@gmail.com. So before starting with any session, first of all, you and me have to thank God for giving me this golden opportunity to deliver this useful talk to share my knowledge among my fellow national and international participants. So thank you, my dear. So this particular class, we are going to go with the introduction to computer, and then we are going to discuss about evolution of computers, classification of computers, and then application of computers. Right. So with a short introduction about a computer, so like every one of us are using computers in one way or the other. Like for example, you use computer, you use mobile as a computer, or maybe you use a laptop. Maybe you use a desktop. Like in any field, like maybe in medical field or maybe engineering, like in handling online classes, or maybe you do some operations, you get some tips, or maybe suggestion or maybe advice from your doctor, maybe to maintain social distancing. He or she maintains a teleconferencing based approach, or maybe you carry your research across different organizations. For example, you are in Uzbekistan, or maybe some maybe in different fields, even in Azerbaijan or maybe like Kazakhstan. You tend to collaborate research in several ways. Okay, so not only in this sophisticated areas, but also in daily lives. You cannot imagine a life without computer. Okay, so they are present in everywhere, and even with the cars, even like you monitor the traffic, you use this application in cars, maybe in mobile games, even with the case of washing machines, you try to go for automatic and semi-automatic based approach. You use computers in microwave ovens, even day-to-day computers for internet banking, railway reservations, or maybe sending emails, electronic mails, internet. You use computers. So actually, the word computer is derived from the word compute. So compute means you are going to calculate. Okay. So you can use a computer as a super fast calculator. You can compute the particular computation in maybe microseconds or maybe even nanoseconds even. Fine. So actually, the word computer is derived from the word compute. So you can imagine the computer to be a super fast calculator. Like you can calculate any calculation within many microseconds or maybe nanoseconds. So it is having the capacity to solve arithmetic or maybe scientific problems at a very jet speed. Okay, like for example, if you have to add two numbers or maybe multiply two numbers, for example, if you have to sort two numbers, or maybe you have to select one particular part, or maybe you have to move from one part to another part, or you have to store information, or you have to compare both these information. So definitely you can use a computer. Okay, so you can use arithmetic and logic operations, maybe in alphabetic or maybe numeric or any type of information you can use a computer. So information is actually raw data. So in the raw data you are going to feed into the system, and it is being presented into the computer in its computer understandable form. So first of all, you should understand, like whatever you try to feed into the system, it it is being coded as a machine language program, and it becomes understandable to the computer, and then it gets the function, or it performs the function, it analyzes the function, right? So this information which is provided by the user, it's fed as the input information or the input data, and then it is being programmed and it is analyzed, and after that it is computed as well. So this is actually a set of instructions given to the computer to perform various operations. So in a computer program, we are converting the input data into the output form, what you call it to be the data processing. So in data processing, you process the information based on the input which is given, and you process and you get the output. So computers, you can also call it as the data processors. So these data processes are very fast, and similarly, similar to the fast data processing, it processes the data very accurately. So you get the data and you perform some operations, and you store the data and you produce the results step by step. So like in the computer, like it has its own algorithm, it provides, or it produces the analysis program, it executes the program step by step, and it computes the outputs. So in the hardware, it's actually the machinery itself. So normally you have like physical parts or maybe devices. For example, you have like ICs, electronic integrated circuits, or maybe magnetic storage media, or maybe other mechanical devices, like maybe the input devices or maybe the output devices. So these devices are inbuilt as a machinery part. So in a computer, you have like both hardware and software. In hardware, you have integrated circuits or ICs, storage media, what you call it to be the magnetic storage media, or maybe the input devices, or maybe the output devices. And similarly, with the case of several hardware you used in computers, the earlier generation computers, they used vacuum tubes, which are the first generation computers, and after that they used ENIAC, electronic numerator, integrator, and calculator, and similarly you use large scale, ultra large scale integrated circuits. What you call it to be VLSI, very large scale integrated circuits. So similar to the computer hardware, you use software. So computer hardware is not capable of doing things on its own. So it has to be given like explicit instructions to perform this specific task. So computer program you use for processing the activities of the computers. So computer generally programs functions according to the instructions which is written in the program. So generally in the software, it consists of computer programs or maybe procedures, or maybe documentation which is used in the operation. So a collection of programs is actually a software which is used to enhance the capability of the hardware. With the case of evolution of computers, like computers are developing every now and then. To fully understand the impact of computers on today's world and the promises, it is important to understand the evolution of computers. For example, the first generation computers, you use vacuum tube technologies. Also, you can use punch card system even. You can use paper tape even for computing the output, or you can use machine language program for writing programs. Okay, so earlier used computers, they used vacuum tube technology, or maybe punch card system, or maybe you can use paper tapes even. You can use machine language program for writing the programs, and you can use magnetic tapes and drums for external storage. So these type of technologies, they used more amount of memory, so that's the reason we use chips, very small chips, or maybe integrated circuits, or maybe very large scale integrated circuits to store the data. So this is actually the evolution of computers. So computers of the first generation were very bulk, okay, very bulky, and they consumed or maybe emitted too much of heat. So you require ACs or maybe air conditioning to actually compensate the heat which is evolving out of the computers. So the computers are large in size and very difficult to handle. They have to be manually assembled. So any small error or maybe any problem, generally it requires reassembling. And also it had like a limited commercial use. So very recently we are using OS, operating system, but earlier during those days we were not using operating system. So every computer had a different binary coded program. Okay, right? But normal modern use computers, they follow a very unique, very regular pattern of binary coded program called as the machine language program. For example, in the punch cards, like line by line, you punch the cards. So any error, then definitely you have to break the entire statement and then you have to go for the next page. And similarly, with the case of paper tapes, with each barcode that is being generated, it is being identified as a character or as a number. And as a vacuum tube, so you store the information in the vacuum tube. So whatever the information you try to store, it requires more amount of vacuum tubes. So with the case of evolution of computers, like abacus, like like this, like 1, 2, 3, 4, you try to do this abacus fashion, which emerged about 5,000 years ago in Asia Minor and is still used today. For example, if you have to compute a large number, like multiply two larger numbers, you can still use this abacus means to allow users to make computations using a system of sliding beads arranged on a rack. For example, if you see in this first diagram, it is actually sliding beads arranged in the rack. So, arranging the beads, it helps to compute very large numbers. So, early merchants used abacus to keep trading transactions, and this is actually how abacus is being evaluated in a very large scale interface. So this is Pascal, Blaise Pascal, who's a French mathematician. He invented a Pascaline machine which can actually perform, add between two numbers or maybe subtract the larger number, smaller number from the largest number. Okay. So this was during the 17th century when Colmar, a Frenchman, invented a machine for four basic arithmetic operations for addition or maybe subtraction or multiplication and division. Okay. So Colmar actually designed a mechanical calculator called as arithmometer. So it's actually a more practical based approach for computing. So with this enhanced versatility with the arithmometer, so it was widely being used in the First World War. So later inventors they enhanced Kalma's calculator together with a fellow inventors. So with the advent of both the Pascal and Leibniz, they took mechanical computation to the next higher level. So it was Charles Babbage who actually invented the first analytical engine or the reference engine, what you call it to be the modern computer. So this machine could be programmed by instructions coded on punch cards, and generally it had a mechanical memory to store the results. So that's the reason the computer it's being used in modern practice, and Charles Babbage is proudly and very fondly called as the father of the modern digital computer. So we study about the early computers. The Mark One. This was the first fully automatic calculating machine. Actually, it was given by the Harvard University in collaboration with the IBM. So it's an electronic relay computer. So in electromagnetics, signals are being used. Okay, both electrical signals and magnetic signals are being used for the movement of mechanical parts. So, Mark I computer generally used basic arithmetic and complex equations. So, this machine was considered to be extremely reliable, but it's very slow. Okay, but the modern computers can calculate within microseconds or maybe nanoseconds. But Mark I computer, it took around 3 to 5 seconds for calculation. Okay, also its design is very complex and it is very bulky and very large in size. And the most common computer is ABC, Attendance of Berry computer. So it's actually developed and maintained by John Atanasoff and Clifford Berry. So it's actually a general purpose electronic digital computer. So it was using vacuum tubes for internal logic and capacitors for storage. So it used capacitors for storage, and it is using vacuum tubes for uh, uh, generally maintaining the internal logic as well. So the earlier computers generally it used ENIAC, electronic numerator integrated and calculator. So it was generally produced by partnership between the U.S. government and University of Pennsylvania. So uh, earlier computers they used several vacuum tubes, like 18,000 vacuum tubes, 70,000 resistors, 1,500 relays, and nearly it consumed around 160 kilowatt of electrical power. So this ENIAC generally it was very faster, like 1,000 times faster than Mark One. But the disadvantage of using ENIAC is that it used too much of vacuum tubes, like 18,000 vacuum tubes, or maybe 70,000 resistors, or maybe 1,500 relays even. Okay, which are very fast than Mark One computer. Okay, so it could store and manipulate only limited amount of data, but it is very fast. That's the only advantage. With the case of program modifications or maybe detecting errors, it was very difficult. Taking you to the next higher level, okay, which is 8 back, okay, EDBAC, okay. So it is electronic discrete variable automatic computer with a memory to store both the program and the data. It was developed during the mid 1940s. So this was actually the first machine which used a stored program concept. So earlier during the days we have to store it every now and then, but this 8 back actually you use a stored program concept. It had 5 distinct units. For example, for arithmetic part, for addition, subtraction, multiplication, division, and after that it had a centralized control. Okay, a management part, and then it had a memory which has a stored part, and then you have an input as well as an output. Okay, and the key element was the central control where you manage the functions. Okay, so all functions are being coordinated using a single source, which is nothing but the central control. Okay, so you use a machine language program for programming the part, and from 8 back, which is nothing but electronic discrete variable automatic computer with a memory, and comes the UNIVAC. Okay, so which is a universal automatic computer, which was the first general purpose commercially available computer. So from 8 back, you go with UNIVAC, which is Remington Rand, who actually designed the universal automatic computer. So this was actually UNIVAC uh, uh, for the first commercial available automatic computer, and it is recommended that you should not touch it. Okay. So next comes the second generation computers. In the second generation computer, the vacuum tube technology was replaced by transistorized technology. So the computer size gets reduced in the second generation computer. In place of the machine language program, you use assembly language program. So you use an algorithm where you compute the instructions step by step and you compute the output. Okay. So stored program concept comes with the second generation computer. The size of the computer becomes, from bulkier state, it becomes reduced. Okay. From assembly level language program comes the advent of the high level language program. So here you use transistorized computers. So in the first generation computers, you use vacuum tubes. So in place of vacuum tubes, use transistorized computers. So the size of the machine started shrinking. Okay. So the computers were smaller in size, were able to compute faster. It is more reliable and more energy efficient as well. Okay, so the first transistor-based computers you use TX0. Okay, so the first large-scale machines, they took advantage over the transistor technology, like with the collaboration of IBM and large technology. This was actually developed by the atomic energy laboratories. Even with the case of modern computers like Honeywell, maybe General Electric computers, or maybe IBM 1400 or maybe 7000 series, they use second generation computers. And by the way, do you have any doubts or clarifications with regards to first generation or maybe second generation computers? Do you have any doubts or clarifications? Do you have any doubts or clarifications? Students, kindly listen. Just look onto the slide. This is actually a picture of the second generation computer with the case of IBM 1401. Are you all listening? Are you all listening?
Yes, yes.
Okay, right. So this is IBM 1401. This is actually similar to your transistor. It was universally accepted throughout our industry, and most large businesses routinely processed financial information using the second generation computers. So the second generation computers use this type of the transistors. So the machine language, you replace it with the assembly language, and after assembly language you use with the high level language program. So the longer and difficult binary code was actually replaced with the abbreviated programming code. So this is actually easy to understand. Okay, right? So this is the case with the case of second generation computers. So here, as I've already mentioned, we use a stored program concept. You use a programming language which gives better flexibility. So it's a very economic solution. Like the computer size gets diminished, and it's very economic as well. And you can use it for business use. So here, with the case of stored program concept, here the instructions to run a program for a specific task were held inside the computer's memory. So, like after the assembly language program, you can use high-level languages like maybe COBOL or maybe Fortran or maybe ALGOL programs even, which are high-level programs which replace the the assembly level language program. So now the computers being used for very vast and varied applications. Software industry began to boom, and everybody started to use a computer as their career. Next, after the second generation computers comes the third generation computers. You use ICs or maybe integrated circuits. The computation speed becomes to increase, and there is reduction in size and power consumption even. And they were using magnetic tapes and drums for external storage, and you use and design operating systems and your higher level language programs, like for example Fortran or maybe COBOL or maybe ALGOL even, where there is commercial production of computers. You use computers for commercial use, so there is a computer for every poor man. Okay. So this generation was actually characterized by invention of integrated circuits, you build into a small chip which were made from quartz crystal even. So after the second generation computers, next comes the third generation computer. So, in the third generation computer, even more components were fitted on a single chip called a semiconductor. The size becomes reduced, the weight consumption, weight becomes less, power consumption is very less. So you use this ICs, okay, or maybe the semiconductor, okay, which has a heavy emphasis being given to the development of the software. So operating systems were designed which allows machine to run many programs simultaneously. So you use several programs at a time, so that it becomes handy in use. So a central program is being monitored and coordinated so as to build the computer's memory. So multi-programming concept was being introduced during the third generation computers. So the machine could perform several jobs. For example, with the case of electronic numerator integrated in calculator, one function is made to use and after that the second function. But with the case of multi-programming, you can use several programs at a time. So commercial production become easier and cheaper. With the case of higher level language programs, with the case of maybe Pascal or maybe report program generator, it is being introduced, and several programs like Fortran or maybe COBOL or maybe ALGOL or maybe PL, it is being developed as a high level, enhanced level language program. So this is actually photo or maybe an image of a semiconductor or maybe an IC that is used in practice in the third generation. Next comes fourth generation computer. So this is actually general features of fourth generation computer. You use very large scale integration and you use microcomputers even. So after computers comes microcomputers, and after microcomputers comes PDA, personal digital assistant or personal computer. You call it to be PCs. Okay. So networking function became deeper. Everybody were able to use networking functions. For example, local area network or maybe wide area network. You use fourth generation languages in order to better understand and compile and execute a fourth generation computer. So here you use very large scale integration, microcomputers, personal computers, enhanced networking function, and fourth generation language in order to compute the fourth generation computers. So this is actually an image of a fourth generation computer. This is actually VLSI, where you try to incorporate the fourth generation language into the computer. So in the fourth generation computer, rather than large scale integration, you use small scale integration. So here in the third generation computer, generally it use ICs. Okay, in the ICs there would be 10 components, or maybe to the utmost it may be 20 components on each chip. Okay. This was actually small scale integration, but fourth generation computers you use LSI, large scale integration, or maybe if there are several components, you use very large scale integration. In very large scale integration, there would be thousands of components in a single chip. For example, you use Intel 4004 chip, located on all components of computer on a single chip. So micro computations are being introduced in the very large scale integrated circuits. So with the case of storage media, magnetic disks have been developed. So fourth generation languages were evolved in order to make the fourth generation computers even more popular. So with fourth generation computers, networking function became developed several components. maybe 1,000 components, 10,000 components were being inbuilt in the fourth generation computers. So, are you understanding the fourth generation computers? Everybody, everybody understood the fourth generation computers? Uh, guys, are you all listening? Are you all listening? Okay, good. I suggest everybody to keenly listen to the slides because this history we should know about it. Like we are using mobile phones, we are using laptops. Everybody is using smartphones, but you should understand the technology. Only then our new technology becomes more interesting. Okay. Right. So, with the case of fourth generation computers, the computer production becomes inexpensive. Like the seventh generation computers, seven computers are being commenced. In 1981, IBM, okay, introduced its personal computer for use in office, home, and schools. Normally, the computers would be used in offices. But in 1981, IBM introduced a personal computer where you can use the computer in office or maybe home or maybe school even. Okay, so it actually Macintosh was the first was developed by Apple during 1984. So they use shared interactive systems and user-friendly environments, which were the features of the computers. Okay, so computers became more and more powerful. The collaboration functions or maybe networking functions, the hardware and the software become more popular in practice. Okay, so networks could reach enormous proportions with the case of local area networks with the connection of internets, computing of functions, and linking of computers. Worldwide usage became handy in practice with the fourth generation computers. After the fourth generation computers comes fifth generation computer. So you use the fifth generation computer as a more difficult way, but still it is more reachable to every individual. So computers of tomorrow, you call it to be the IoT or maybe artificial intelligence, where you have a AI expert to actually build this type of computer. So computers could be developed which could think and it could have a reasoning capability in much the same way as human. But it is very dangerous, to handle such specimens. Like I hope you would have come across movies or maybe films where where a computer or maybe a robot can artificially think like a human being. We might think about computers as human beings, but the thing is that it's very dangerous. Like you might have, hard emotions like human beings, which can drastically become dangerous. Like a human being cannot do, a robot can actually do. So computers would be able to accept spoken words as input. For example, in YouTube, you use a microphone to translate or maybe get what is actually. For example, you feel very lazy to type in YouTube. Okay, right? So you use a microphone and compute it. Okay, you say some words and it actually converts it into words and it types it accordingly. Okay, so this is actually voice recognition. So there are several advances in the science of computer design and technology even, so which are making fifth generation computers very handy in practice. So one such application is parallel processing, where many CPUs they work together and they advance in the supercomputer technology, which allows the flow of electricity with little or no resistance, which generally improves the speed of information flow.